Right now, at this exact moment, your car's engine computer is actively lying to you. It has been lying to you for months, possibly for years, and every single time you pull up to a gas pump and watch those dollar numbers spin past what you budgeted, that lie is costing you real money. Every time your engine stutters at a stoplight, every time you feel that hesitation when you press the accelerator and the car seems to think about it for half a second before responding, you are experiencing the direct financial consequence of a suppressed piece of knowledge that the automotive service industry has buried so thoroughly that it does not appear in a single dealership service manual printed after the year 2001. I am going to hand you that knowledge today in its complete form. I am going to explain the engineering, the history, the exact corporate decision that made this disappear, and then I am going to walk you through a repair that costs you nothing, takes 15 minutes, and will permanently restore your fuel economy and your smooth acceleration. The dealerships charge $500 to pretend to fix this same problem. When this video is done, you will never pay that bill again. Let us start with the invisible math happening inside your engine right now, because unless you understand what is actually being corrupted, you will not fully grasp how elegant and how maddening this whole situation truly is. Your engine does not run on a fixed formula. There is no hard-coded setting that says inject precisely 14.7 parts of air for every 1 part of fuel and hold that ratio forever. Instead, your car runs a continuous, living negotiation. The engine control module, which engineers call the ECM, is constantly sampling data from a network of sensors. The oxygen sensor positioned in your exhaust stream is reading the chemical composition of your spent combustion gases several times per second. The mass airflow sensor is measuring the precise density and volume of every breath of air entering the intake. The throttle position sensor is reporting exactly how far your foot has pushed the pedal. All of this data is flowing into the ECM in real time, and the ECM is making thousands of micro adjustments per minute to the fuel injector pulse width, which is simply the duration of time each injector stays open and sprays fuel into the cylinder. This system has 2 layers of adjustment. The first layer is called short-term fuel trim. Think of it as the ECM's immediate reactive response, the equivalent of a chef tasting a sauce and reflexively adding a pinch of salt right now, in this moment, to correct what is slightly off. Short-term fuel trim corrections are fluid and temporary. They exist entirely in volatile working memory and disappear the instant you turn the ignition off. The second layer is the one that matters for everything we are about to discuss, and it is called long-term fuel trim. This is the ECM's permanent lesson file. When the ECM notices that it has been making the same short-term correction repeatedly, day after day, it concludes that a permanent underlying condition exists. It writes that correction into a protected section of non-volatile memory called Keep Alive Memory, or KAM. This memory is specifically designed to survive engine shutoffs. It draws a tiny trickle of current directly from the battery at all times, even when your car is parked in your garage at 3 in the morning, specifically so that these learned adaptations are never forgotten. Here is where the trap is hidden, and here is where your money starts disappearing. Imagine you filled your tank at an unfamiliar gas station during a road trip 6 months ago. That tank had a slightly different ethanol blend than your ECM expected. Or imagine that last winter, during 2 consecutive months of extreme cold, the denser air was consistently throwing your air-to-fuel ratio lean. Or maybe you had a clogged air filter for 3 months, and the restricted airflow trained your ECM to compensate with extra fuel. Your ECM, doing exactly what it was designed to do, learned from these conditions. It wrote a corrected fuel map into Keep Alive Memory. It shifted your long-term fuel trims to compensate for a condition that no longer exists. The bad gas was burned 2,000 miles ago. The air filter was replaced. The winter ended. But the learned adaptation, the scar in the memory, is still there. Your engine is now permanently running a fuel strategy optimized for a problem that has been solved, and that corrupted fuel map is costing you somewhere between 12 and 18% of your total fuel economy every single tank, every single day, until that memory is erased and the ECM is forced to start its learning process fresh from a clean baseline. To understand why this knowledge was buried, you need to understand a specific date, January 1, 1996. That was the federal deadline by which every car sold in the United States was required to comply with onboard diagnostics 2, universally known as OBD2. The federal government mandated this system primarily to tighten emissions enforcement. Regulators wanted every car to be self-monitoring, capable of detecting and reporting its own emissions failures so that owners could be legally compelled to fix them during state inspections. The engineering teams who built the OBD2 adaptive learning system were brilliant. They created something genuinely elegant. The adaptive fuel trim and Keep Alive Memory framework meant that a single engine calibration could self-optimize across an enormous range of driving conditions, altitudes, fuel quality variations, and component wear patterns. It was a masterpiece of adaptive control theory applied to mass-market engineering. The dealership network saw something else entirely. Within 18 months of the 1996 OBD, 2 rollout service departments across the country began noticing that customers were coming in, complaining about rough idle, hesitation, and poor fuel economy. Exactly the symptoms of corrupted long-term fuel trims. These were not mechanical failures. There was nothing physically broken. A trained engineer looking at the live data stream from the OBD2 port would immediately identify elevated long-term fuel trim percentages, pull the ECM fuse for 15 minutes, clear the adaptive memory, and send the customer home. The fix required no parts, no chemicals, and about 20 minutes of a technician's time. At shop labor rates, that visit should have cost the customer $40 to $60 at absolute most. Instead, the service industry built an entirely different narrative around these symptoms. They gave the problem a name that sounded expensive and physical: carbon buildup. They created a treatment protocol that sounded scientific and necessary: the fuel injection deep clean. They sourced bulk quantities of generic solvent chemicals, rebranded them with proprietary names, and packaged them into service line items that regularly invoice between $400 and $600. The carbon buildup narrative was not entirely fabricated from nothing. Carbon deposits on intake valves are a real phenomenon, particularly in direct injection engines. But the symptoms of actual physically significant carbon buildup severe enough to cause rough idle and fuel economy loss look dramatically different on a diagnostic scanner than corrupted adaptive memory does. Any technician running a proper live data analysis can tell the difference in under 3 minutes. The profitable choice was to not run that analysis. The profitable choice was to recommend the flush, collect the payment, and send the customer home with a clean invoice and, in many cases, a car that felt somewhat better simply because the act of running the engine through the diagnostic cycle and disconnecting various components during the service procedure had incidentally caused the ECM to reset some of its adaptive learning. The chemical flush did some of the work. The inadvertent memory disruption during the service did the rest. The customer never knew which part actually helped, and the dealership certainly was not going to clarify. The proof that this is the reality and not speculation is dense and comes from multiple directions. Commercial fleet operators, the people who run hundreds of identical vehicles under controlled conditions and track every variable with engineering rigor because their margins depend on it, have documented this phenomenon exhaustively. Long-haul trucking companies operating fleets of identical diesel units with OBD2 adaptive systems have internal maintenance protocols that mandate periodic adaptive memory resets as a scheduled preventive procedure, timed to fuel economy benchmarks rather than to mileage or calendar intervals. These fleets have internal data comparing units that received routine memory resets against control units that did not, and the fuel economy delta in the controlled groups consistently falls between 11 and 17%. That is not a rounding error. On a fleet operating 50 vehicles and spending 6 figures annually on diesel, that percentage represents real and substantial savings. Independent automotive engineers and former OEM calibration specialists who have spoken publicly about this have consistently confirmed that the CAM reset protocol is standard. Internal knowledge at every major automaker's engineering division. It appears in internal diagnostic training materials. It is a standard step in the calibration reset procedures that engineers follow when flashing a new ECM tune to a vehicle. It has simply never been included in the consumer-facing owner's manual or the service interval documentation provided to dealership service writers. Now, let us talk about the exact procedure, and let us be very specific about why you are going to do it with the ECM fuse and not by disconnecting the main battery terminal, because this distinction matters enormously, and the difference between these two approaches is the difference between a free 5-minute job and a potentially expensive afternoon of problems. When you disconnect the main battery terminal, you are cutting power to every single module in the vehicle simultaneously. Modern vehicles have between 30 and 80 separate control modules depending on the trim level. Many of these modules, particularly the radio and infotainment system, the climate control module, the power window and seat memory modules, and the anti-theft system, have their own security protocols and anti-tampering routines that trigger when main battery power is interrupted without warning. The most common and expensive consequence is a radio security lockout. Many factory radios, particularly those installed in Honda, Volkswagen, Acura, and various European brand vehicles from the late 1990s through the mid-2010s, will display a code prompt after a battery disconnection and will remain completely non-functional until you enter a specific 4 or 5-digit unlock code that was originally provided in the vehicle's documentation. If you do not have that code, and most people do not, retrieving it from the dealer requires proof of ownership and ranges from a $20 fee to a $150 diagnostic visit, depending on the brand and model. Beyond the radio, disconnecting the main battery also wipes the idle relearn data from the throttle body control module and the power window one-touch auto feature calibration, both of which require specific relearn procedures to restore. The ECM fuse bypass avoids every single one of these complications because it cuts power to only the engine control module and nothing else. Every other module in the vehicle remains powered and undisturbed. Open your hood and locate the fuse box. On the vast majority of modern vehicles, it is a black rectangular plastic housing positioned near the top of the engine bay, usually toward the driver's side front corner. It will have a removable lid, and on the inside surface of that lid, or on a label affixed to the inside surface, you will find a printed diagram mapping every fuse in the box to its corresponding circuit. You are looking for the fuse labeled ECM, EFI, or engine control. On some Ford products, it is labeled PCM for Powertrain Control Module. On many Toyota and Lexus vehicles, it is labeled EFI. On most GM vehicles, it is labeled ECM or ECM BAT. The fuse will typically be a standard mini-blade fuse rated at either 10 or 15 amps, and it will be blue or red respectively. Pull it straight out using the small plastic fuse puller tool that is stored in a designated slot inside your fuse box lid, or use a pair of needle nose pliers if no puller is present. With the fuse in your hand and the ignition in the fully off position, set a timer for 15 minutes. This duration is not arbitrary. The capacitors inside the ECM that maintain residual voltage in the cam circuit after fuse removal will fully discharge within approximately 8 to 12 minutes under most temperature conditions. The additional buffer ensures complete discharge even in cold weather, when capacitor discharge rates slow measurably. Do not reinstall the fuse in less than 15 minutes. After the timer completes, reinsert the fuse firmly until you feel it seat fully. Close the fuse box lid. Start the vehicle and let it idle without touching the accelerator for a minimum of 10 minutes. During this period, your ECM is running its cold idle relearn sequence, reestablishing its baseline throttle position and initial fuel trim starting points from a completely clean slate. After 10 minutes of stationary idle, take the vehicle for a drive that includes a variety of conditions. Spend some time at low city speeds, some time at steady highway cruise, and include a few moderate acceleration events. Over the course of the next 100 to 150 miles of normal driving, your ECM will complete its full adaptive learning cycle and converge on a new, optimized long-term fuel trim map tailored precisely to your current fuel quality, current air filter condition, current temperature conditions, and current injector behavior. Most drivers report noticing the improvement in throttle response within the first 20 miles after the reset, and the full fuel economy restoration typically registers clearly over the course of one complete fuel tank. The entire procedure cost you nothing. The fuse tool was already in your fuse box. The 15 minutes cost you exactly 15 minutes. You just performed a repair that a dealership would have invoiced at $500 minimum, and you did it with better understanding of the underlying engineering than the service writer who would have handed you that invoice possesses. What you just did is something they counted on you never knowing. The $500 fuel injection flush exists as a line item specifically because the automotive service industry calculated correctly that most car owners would interpret unfamiliar engine symptoms as physical, mechanical problems requiring physical, chemical solutions. The invisibility of software adaptation as a failure mode was the perfect cover. You cannot see corrupted memory, you cannot smell it or touch it. You can only feel its symptoms, and those symptoms feel exactly like something mechanical is wearing out. They design the customer experience, the language, the invoicing, the service advisor scripts, all of it, around keeping you thinking in physical terms about a problem that lives entirely in software. That protection is gone for you now. Share this video with every person in your life who owns a car, because the $500 flush is not the only service on that dealership menu that exists, purely because they assumed you would never understand what was actually happening inside your engine. The next video I am releasing is going to expose something far more disturbing. It involves a specific liquid that every dealership service department in the country adds to your engine oil during a standard oil change, without disclosing it on your invoice. A petroleum industry byproduct that temporarily reduces the sound of engine wear to pass the noise check on the lot, while simultaneously accelerating long-term bearing wear in a way that guarantees you will need a short block replacement between 80 and 100,000 miles. I have the internal supplier documentation, I have the fleet comparison data, and I have the name of the additive, the exact bottle it comes from, and exactly how to test whether it is in your engine oil right now. Hit that notification bell. This one is going to make today's video look like a parking ticket.